In the last chapter, we talked about a single server can handle all of the traffic for a small website. So this server will typically handle both the web tier, which is the code that runs on the website, and the data tier, which is the database that stores the website data. So in a single server setup, this web server and database are on the same machine. So this is fine for small applications with a limited number of users. As the user base grows, these servers will eventually become overloaded. In this chapter, we were talking about how a website can be scaled to handle a growing user base. Technically speaking, which is how to scale a web application from one server to multiple servers. As the user base grows, the single server will eventually become overloaded. So at this point, it is necessary to separate the web tier and the data tier onto different servers. So this allows each tier to be scaled independently. This is a common way to architect a website or a web application for scalability, which is a three-tier architecture with a web tier, a database tier, sometimes a middle tier that can be handle things like load balancing or caching. As the user base grows, there is a need to scale the architecture, which is splitting the web or mobile traffic handling from the database operation is a foundation move towards scaling and improving the reliability of the system. So by doing this, each tier can be scaled independently. For example, we can add in more servers or resources based on our demand. So user can interact with a web server via a web browser or a mobile app, and then the web server is interacting with the database. So this setup is indicative of a three-tier architecture commonly used in web applications, which separates the presentation layer, the application logic layer, and the data layer. In the multi-server setup, the web server and the database are on separate machines. This allows you to scale each tier independently, so you can add more web servers to handle increased traffic, or you can add a more powerful database server to handle more data. So this architecture allows you to scale each tier independently. The web tier is responsible for handling user requests and responses. It typically consists of web servers that run the application code which serve static content like HTML, CSS, and JavaScript. So this web tier can be scaled by adding more web servers. This will distribute the traffic among the servers so that no single server is overloaded. The database tier stores the application's data. It can be a single database server or a cluster of database servers. So the database tier can be scaled by using a distributed database or by replicating the database on multiple servers. So if your database is getting overloaded, you can add more database servers to the database tier, or database replication can be used to create copies of the database on multiple servers. So this can be improve the fault tolerance and performance, and will increasing the database capacity to store data and handle queries. The middle tier sits between the web tier and the database tier. It can handle tasks such as load balancing, which distribute traffic among multiple web servers. This helps us to ensure that there's no single server is overloaded, so that we can improve the website's performance and availability. And the second one is caching, which stores frequently accessed data in memory so that we can reduce the load on the database. Overall, this three-tier architecture is a good starting point for scaling a website or a web application. So just by separating a web tier, the database tier, and the middle tier, you can make your own application more resilient and scalable. So this separation of concerns not only allows us for target scaling, but also improves the overall system resilience, since the failure of one tier doesn't necessarily lead to the collapse of the entire system.